xz, x and y, you can mix these with z and get all those other possible portfolios and so forth. So ultimately, you end up with a graph that is represented by this thing. This is the feasible set. This is the minimum variance portfolio. How do we call this part right here?
Efficient frontier.
The efficient frontier, if I only know how to draw it. And so the objective of this project is to trace the efficient frontier with 3 assets. So remember, we were able to figure out a formula to calculate the minimum variance portfolio for 2 assets, but we don't have one for 3. So let's see how we can trace this thing. What could be the logical steps? Expected returns and risk. Whatever, I'm just making stuff up here. So one way to trace it is to pick a level of expected returns and then look at all possible ways I can mix x, y, and z so that the expected return of this mix is, say, 2%. So turns out there is an infinite number of ways to mix those 3 assets and get 2% as a return. But out of this infinite number of ways, I want to figure out a one such that find the subset of weights such that weight of x, weight of y, weight of z, such that the risk is minimized. So, for instance, the way I can mix those assets and get a return of 2% could be linked with all those different levels of risk. But out of all those, I want to retain the weight that gives me that, the smallest amount of risk. Then I can repeat the same thing for, say, 3%. So I want to look at all the portfolios that I can get so that the expected return is 3%. But out of those, I want to find the weights such that the risk is minimized. So for instance, I can create all of those portfolios that have this expected return of 3%. But out of all of those, I want to figure out the one that gives me the smallest risk. Repeat that for all those different levels of expected returns, and you should be able to trace this thing. So far we have traced the frontier. Once you identify out of all those portfolios, each of them has an expected return that you established and a risk that can be calculated. Out of those, identify the minimum variance portfolio. So there is one combination that gives you the smallest risk. Then the next step is, well, what if there is also a risk-free asset in there? So if there is a risk-free asset, and this is the rate, then if you can calculate the Sharpe ratio, for each of those portfolios, or each of the ones that you get, there is going to be one that has the highest Sharpe ratio. So once you find the set of weights with the highest Sharpe ratio you found, there will be. Yep. So by doing this, using the data that you have, you would have found the best possible asset allocation given those 3 assets using this historical data. This is not necessarily, we haven't talked about that, this is not a prediction of what is going to happen next. In the future, the ORP could be totally different, right? This is only based on the data that you have collected. So one way to kind of push this a little bit forward is, well, over this time period, you calculated the ORP using 3 ETFs instead of all 10 that you have. And how does this portfolio compare to a broad class of assets? Like, how does it compare to the S&P 500? How does it compare to the Dow Jones? So, if this is the case, how does this ORP compare to the S&P? Which one is better, the ORP or the S&P?
The ORP.
Are you sure?
Best returns for the funds.
Or alternatively, it has what, has a higher Sharpe ratio, right? If you draw a line from here to there. Or one way to also say that is, well, look, if I wanted to be exposed to this much risk, I could achieve this portfolio right here by doing what? By shorting T-bills and investing the ORP. I would have the exact same amount of risk, but I would have higher returns. So clearly ORP is better than S&P in this case. So you would have all outperformed the ORP. What about with respect to the Dow?
That's just
The Dow would have had a higher
Yeah.
Sharpe ratio, so in this period it would have underperformed relative to the Dow. Okay, so I don't know what you're gonna get. I mean, you're using market data. I don't have an idea how the, what you're gonna find, but definitely should be able to trace this thing. Now let's go back a second. So make sure you write this stuff down. How do you compute the expected return of a 3-asset portfolio? Is the weight of X, expected return of X, weight of Y, expected return of Y, and
Where is he?
weight of Z, expected return of Z. So it's the weighted average of the expected returns. Yeah. What is the constraint on the weights? Weight of X plus weight of Y plus weight of Z is equal to 1. Do you agree with that? If shorting is not allowed, what additional restriction do you have?
None of those could be negative.
That
Negative.
Positive.
all of them must be positive or possibly equal to 0, right? You can have no position in one. So that's an additional restriction that you have. What if you can only short Z?
Well,
Then
Z
the weight
is
of Z can be
Negative.
negative. Yeah.
Yeah, true.
What additional restriction do you have? That's implied there, but it does have to be all positive. But assuming that you can short one, then maybe you might have an additional restriction saying that you cannot invest more than a certain amount in either of the assets. Okay, so what you have to say that each weight can be at the most 1.1 or whatever. What about risk? This one is complicated, right? So the variance is the weight of X, sigma X squared, weight of Y, risk of Y squared, plus weight of Z, risk of Z squared, plus twice weight of X, weight of Y, covariance XY, twice weight of X, weight of Z, covariance X and Z. What is left?
The last one between
Y.
Wine.
Z, covariance Y, Z. Yeah? And so the formula for risk is gonna be this one. So once you find the variance, can you find the standard deviation?
Yes.
Sigma p is gonna be just the square root of the variance, right? So you can do all those calculations possibly step by step. So the first thing that we're gonna need is the input list. What are the information that we have? So if you remember that project number 3, you end up getting something called a covariance matrix. And so you have X, Y, and Z, X, Y, and Z. And you have a table with numbers. And the numbers that are on the diagonal of this thing, this is gonna be the variance of x, variance of y, variance of z. Yep. And then off the diagonal you have the covariance between each possible pair. Covariance xy, covariance xz, covariance yz. Okay? So, in order to calculate the monster, this is where you're gonna get the data. And so if you don't have this table done correctly for project 3, there is no way you can have numbers to do this stuff. Not only that, if you do it incorrectly, so assuming that you do it but you did it incorrectly, then this stuff is not gonna work. It's gonna give you answers that make no sense. Yeah. So let's see exactly how to do this stuff. How can you find the smallest risk? So you go to your best friend Excel. Yeah. And I'm gonna start with a blank workbook. Alright, so you will have your spreadsheet with the data. I can hear accounting in the background and I'm getting excited. So your inputs from the other project are going to be, let's say they're here. So let's say I have asset X, Y, and Z because I'm very imaginative. And here I have the standard deviations of the variances and the covariances. Okay, so the numbers I'm going to pick, they're going to be probably nonsensical, but suppose this is the 10%. This is going to be 0.1 squared. That's 10% standard deviation. This is the variance. This is 20%, so it's 0.2 squared. So this is the way I'm making the numbers up, and this is 1.5 squared. Yeah. So you will not have to do any calculations. This is the output of your other things. So so those are your variances and covariances. I hope it's going to work. Now, what are the other inputs that we need? So we have the variances, which is this guy squared. Then we need the expected returns, right? How can you get the expected returns from your data? When you have the list of returns, one way to make the forecast is just do the average and assume that that kind of behavior persists in the future. So here you're going to have your expected returns. Five, 7, or 12, or whatever, I'm making stuff up, and 14%. Yeah? Alright, so what is that we need to do? We need to figure out the weight. So let's start with the weights. This is gonna be the weight of x, weight of y, and weight of z. To be consistent, let me put it right under it. Are those numbers related or totally independent? They are related because their sum is equal to 1, right? So all I need to do is specify 2, and the third one is just going to be, can be calculated. So I'm gonna write that as a formula equals 1 minus these minus that. Yeah? Alright. So what can I do with those things when I can calculate the expected return? So keep in mind now I'm gonna have to write a formula that is not that complicated, but it would be hard to troubleshoot if the answers don't make any sense. So remember naming of cells? Yeah?
Yes.
So I'm gonna take this one and call it, how do you put names? What is the name?
Where's it go? No, usually
It should be here, right?
Yeah, first one good.
That's the-
Is it double click or?
I think it's on the far right, you gotta do the drop down arrow.
Right here?
No, the very
No.
far, very far right.
Far right?
All
Yeah,
the
you
way
have to
to
go
the
and see the formula.
Oh, maybe not that one.
No.
Oh shit. I
Just press-
broke it.
Right click it.
How do you do it? How do you get this
Oh,
thing?
no, it's just, that's crazy. Maybe controls
Just
the
hit
interface.
restore.
Oh, restore.
Oh no, click on the home tab. Click on the home tab. No, the home tab.
Oh, far.
The home
Bar,
tab
just
on the
hit
left.
home
The home button. It says home on your left.
Right
You just
upside
you're
down.
close. You're close.
Right
Ah,
there.
there it is. Yeah.
Pull
Yeah, right
down
there.
menu. Yeah.
And then hit the
Oh,
pin.
okay.
Hit the pin on the bottom right. Bottom right.
Bottom right.
Pin.
Yeah, there you go. Yeah, pin it. There you go.
Okay. Yeah, but I still don't have that stupid thing, right? So it should, formula should be data should be here. Names of cells should be here. Come on, this is easy stuff. I should
I
know.
know, there we go.
Double click into the cell.
I thought it double
Define
click it.
name.
You could define a name, it's just annoying.
I don't want to do it that way. I'll just
Double click
normally
into the
there
cell.
is- Normally there is a window here, but you
Yeah,
can't-
double
Just
click into the
double
cell.
Formula bar.
Double click into the cell.
Double click the cell. The
Yeah. Okay. Maybe view formula bar.
no.
That's what it is.
Hey.
Oh.
There we go.
Boom. There you are.
So,
Solve the mystery. Alright, so I'm gonna call this the expected return of x, and this one expected return of y, and this one is gonna be expected return of z, right? So the way you're gonna write the formula here is this is gonna be expected return of p. And how do you calculate that? Well, it's gonna be the weight of x times expected return of x. And then plus this guy times the expected return of y plus this one expected return of z, right? Right.
It's also just as well.
Right, fine, D12. Great.
E12.
No, E12.
E12, of course you will. This is gonna take a long time. Times the expected return of
Z.
x, y, and z, right? So, okay, easy to troubleshoot. Alright. So let's see if this makes sense. If I invest only in z, my return should be the same as z. So it's working. Alright. Good. So next we need to compute the variance. And this is where it's gonna be fun. So one thing to keep in mind is that the way I can modify this so that I have weight squared times variance of x. You agree with that? Here I have it as a standard deviation, but what I have in that table is the variance. So I can either calculate standard deviations in the spreadsheet and then use this formula, or just modify the formula given what I have. I think this is the easiest thing. So I'm gonna call this variance of x. And I'm going to call this variance of y. And this is gonna be my variance of z, right?
Yes.
Yep. Now I need to define the covariances. This is gonna be covariance of x and y. Covariance x, y. This is gonna be covariance, what's that? X and z.
Mm-hmm.
And finally, this is the covariance between y and z. Got it? Alright. So this is by far the most boring stuff, but now this is the headache. This is going to be the variance of p. Once I have the variance of p, I can calculate the standard deviation of p just by taking the square root of that, right? Yep. Alright, so if my formula is going to be correct, with those weights, what should I get? I'm investing only in z, so the standard deviation of p is going to be the square root of this guy right here. And the variance should be exactly this number. Yeah? Alright, so let's enter the formula here. I have to make this bigger. Alright, so the variance is equal to the weight of x squared, w equals w x, which I didn't name, so it's gonna be this guy. I'm gonna lock it, squared, times the variance of x plus the weight of y, this guy squared, times variance of y plus the last weight, F4, I didn't F4 the other one, but that matters at a certain point, times the weight of the variance of z. Yep. So we just dealt with the variances, and now we need to do the covariances. So plus 2 times the weight of x times the weight of y times who? Covariance xy plus the weight of x, weight of z times covariance xz. Yeah?
Mm-hmm.
Plus
Times 2.
times 2.
Yeah.
Plus 2 times weight of y, weight of z, covariance x, weight z. Yeah? So to make this more legible, maybe label also those guys, name also those cells, so that it's easier to troubleshoot your formula. So at the minimum count the terms, you have 1, 2, 3, and I made another mistake here because I did not square this guy. The weights have to be squared, right? So you need to have 6 terms, and I do have 6 terms. There are the 2's, and let's see if 0.625, 0.625, yeah, we got the right number. Yep. Alright, now clearly we can modify those weights, and by changing the weights all this stuff is going to change. So how can I tell Excel to pick weights so that the return is this much, but the risk is the smallest, the risk of the portfolio is the smallest possible. But if you go to data, Solver is the thing that allows you to run simulations and optimize things. So let's see what this thing says. It says set the objective. So what are we talking about? What do we want to maximize or minimize? We want to minimize either the variance or standard deviation, right? Either one. So let's suppose that we want to minimize these. The two things are the same. So what do we want to do with that? We want to minimize it, and we want to change what? Well, what is it we are manipulating? We are going to manipulate the weights. All right. So if I just do that and click OK, what this thing is going to do is going to pick the weights, all three of them. No, sorry, you're just changing to the other one changes by default. So it's just going to find the weights that give us the absolutely smallest weight. So let's say suppose I click OK here or solve. There it is, it's giving error. What do you think is the case? Well, look at the weights.
That's in line.
It's giving me, it's finding the weights that generates by far the smallest possible number, and somehow that turns out to be negative. Did not give this thing any constraints. So let's go back to OK and start all over again. And wrong thing. So what are the constraints that we have?
Variance.
Well, if you don't allow shorting, then the constraints are that the weights have to be zero. I mean, the cell will have to be greater than or equal to 0. What else?
Same for the rest.
The rest will have to be the same, right? So keep adding.
Oh, yeah.
So cell reference, we want this guy
But those that can be grouped or they
to
can
be, I
separate?
don't think you can group them. I think you have to do one by one. And then the other constraint is that this one has to be equal to 1. Hold on. The sum has to be equal to 1. So I need to create one more, but I put the sum of the weights, and that would have to be equal to 1. Alright, so the other constraint is that I want the expected return to be equal to a specific value. So the other constraint is that the cell containing the expected return, I want it to be equal to. So basically I'm looking at only the weights that generate this particular return that I'm picking. And what is the range of returns? Well, the smallest is 5, the highest is 14. So let's go with 5%, so 0.05. Make a constraint variables negative. Yeah, this is good enough. And I think this is going to get an error. No. So what weights did it pick? If I want a return of 5%, all I need to do is have a weight of x equal to 1, which makes sense, right? The weight of x or 1 is the portfolio with a 5% return. The smallest risk I can get with that is, of course, 10%, which is the square root of that. Of this is the portfolio that this asset allocation is the one that gives you a return of 5% and at the same time has the smallest amount of risk. So just to make sure that things work out every time, this worked, but it's not necessarily the case. that is gonna work every time. This create a column with the sum of weights. So this is gonna be equal to this plus this plus this. What should this number be? It should always be 1, right? So let's add that as a constraint. Additional constraint, I want sum of weights exactly equal to 1. Alright. So what is the next thing? We found that those weights generate a portfolio with expected return of 5% and the smallest risk. So let's pick a higher level of returns, say 0.55, and run it. So we are still investing mostly in X, but now we're investing a little bit in Z, and this is the expected return, which is what we established, and this is the risk of your portfolio. So start copying those values, copy them, and paste special, paste just the values. So this is the portfolio that gives you what? An expected return of this much and a standard deviation of this much. So those are gonna be your Y variable of the graph, and this is gonna be your X data point of that same graph. Okay? So those are the coordinates of this first point. What do you think we're gonna have to do next? You go back to solver, change these from 0.55 to 0.6. And there it is. We got some other numbers. And copy it, paste special, and keep going that. So now we can keep imagine doing this all the way through until you get to the other asset that has a return of 14%. So you're basically moving up. Each set of weights gives you a specific level of risk, which is the smallest risk you can get. So you're getting all those points ready. Now one of those points is going to be your ORP. So you need to be given a risk-free rate. So whatever number that is, and you can use that to calculate the Sharpe ratio. What is the formula for the Sharpe ratio?
Excess return, which
Is the return of your portfolio minus crap. Is the parentheses is the expected return of your portfolio minus the risk-free rate divided by the standard deviation of the portfolio, right? Alright, so copy it. This is as you do those calculations, this number is going to be in there, right? So you're going to have a list of Sharpe ratios, and the ORP is going to be the one with the highest value. Yep. Got it. So keep doing this, build this list, and as you build this list, just maybe start graphing this thing, and make your graph here, and like graph those as your y-axis. So where is it? This as the y-axis, put this on the x-axis, and you can see the graph basically getting populated as you keep adding things to the list. You need to do an xy scatter graph. Don't do a line graph, just do the xy, otherwise you're gonna get some weird stuff. And that's about it. Questions? Can you handle it?
Yes.
How many of you have used the solver before? 1, 2, 3, 4.
Yeah.
What classes did you use it?
Ecostats.
EcoStats, okay.
I was doing it for fun.
Yeah, but I was doing it for fun too.
What did you use it?
Ecostats.
EcoStats, okay. What did you solve for there?
I think we
Do you remember any EcoStats?
That was fun.
To find the standard deviation, okay. So use it. There is a picture or a screenshot of the constraints those are the most important things. So look at the